So since we're talking about derivative, we want to talk about different ways we write the word derivative. So, when you see this, it means derivative. So first thing is you see this little thing here. We call that prime. So y prime is a way of saying the derivative of y. Another way is dy dx. So we say dy dx, or the derivative of y with respect to x. So it's important to know with respect to what. That means that is the variable we're differentiating the function to. Okay, we'll explain that more later. Another way to say it is df dx. So df, f meaning f of x. So instead of saying y, we say f of x. So same idea, the derivative of f with respect to x. And then so another way of saying that is kind of, this is the derivative part, and then this is the function itself. So that happens a lot. So d dx of f at x, but basically just kind of keep in mind this thing, d dx, that's the derivative, and then it could be anything next to it. So just a little quick overview of how derivatives are written. So the next big idea is this differentiability. Differentiability means whether the function has a derivative. So whether the function has a derivative. Oh, sorry, that's an R. Whether the function has a derivative. So how can you check to see if it's differentiable at a point? So we can talk about whether the differentiability happens at a point, or we can say whether the differentiability, whether the function is differentiable for the entire function. So what makes something differentiable and what makes something not differentiable? The first thing is whether the function is continuous at a point. So is the function continuous at that point? If the function is not continuous at a point, it definitely will not have a derivative. So like, if you kind of think about it, if you have a jump discontinuity, then at that point, there is no derivative. Derivative has to happen on a continuous curve. So same thing with infinite discontinuity, then at this point here, well, there's a asymptote to begin with, so definitely no derivative. The second idea is, does the limit as h goes to 0 from the negative side of the differential difference quotient, or basically the derivative, equal to the limit as x goes to 0 from the positive side of the derivative. So are the limit, or basically the slope of both sides, equal? So is the slope, or let's say derivative, from the left and right equal? All right, so let's go ahead and look at a problem together. So this one says, determine the continuity and differentiability at a given point. So here are some ways where, looking at a graph, I'm going to show you some very typical problems that somebody asked about differentiability. All right, we're going to ask two things. Number one, is it continuous? Remember, if it's not continuous, it's not differentiable. The second thing is, well, if it is continuous, then does the left-hand side and right-hand side slope, or another word, derivative, are they equal? All right, so we have this function, absolute value x. The question is it differentiable at 0? All right, so the first thing is it continuous at 0? Yes, it's continuous at 0. Is it differentiable at 0? Okay, differentiable at 0 means what is the derivative from the left and what is the derivative from the right? So the derivative from the left of 0, what is that slope? Remember, derivative means slope. So what is the slope? That is, I'm not sure how to write this. The derivative from x equals 0 minus left of 0, that is -1, right? And then the derivative from the right of 0 is +1. So the left-hand side and right-hand side derivative are not the same. So is it differentiable? No. Okay, yeah, it's continuous, it's connected at 0, but then because the left-hand side and right-hand side slope are different, it's not differentiable. All right, second one. All right, so we have this really interesting graph. First, at 0, is it continuous? Yes, I can draw this without lifting up my pencil. Is it differentiable? All right, so derivative from x equals 0 minus. That is, well, I don't know what that number is, but I know that it has a negative slope. And then the derivative from the positive side of 0, that has a positive slope. So what does that mean about differentiability? Not differentiable. All right, let's look at this one. Is it continuous at 0? Yes. What about the derivative from the left and the right? Kind of looks about the same, right? The left and right of 0 looks about the same. So is it differentiable? This is a little bit tricky. So the next thing you can kind of ask yourself is, if I were to put a tangent line at 0, what would be the slope of that line? Well, let's just try to put the tangent line at 0 first. So if I were to put the tangent line at 0, I would put a vertical line. What is the slope of a vertical line? It is undefined. So since the slope at that line is undefined, we would just say that it is not differentiable because that slope does not even exist. How could it even have a slope? If it doesn't have a slope, it's not differentiable. All right, so this one, we're not quite looking at the left and right of 0 because at 0, there is just no slope. All right, this one, number 4. Is it continuous at 0? No. So we really don't even have to care about the slope left and right because it's just not going to be differentiable. It doesn't even pass up my first requirement. Discontinuous graphs are not differentiable. And if you were only given the idea of slope, if you were to find the slope from the left and right of 0, you would say on the left of 0, that slope is 0 because that's a flat line, and then on the right it's also 0. So then you might be tempted to say that because the slopes are the same, it's differentiable. But remember, the first requirement is it has to be continuous. So this is not differentiable. And actually, in fact, what you want to do is kind of memorize these 4 graphs. These are typical graphs of why things are not differentiable. And if you want to remember, the main idea is any sharp corners are not differentiable. Any discontinuity is not differentiable. Anything that gives you a vertical tangent line is not differentiable. So these are the main 3 things that causes something to be not differentiable. What does it mean if a function is differentiable? So let's kind of ask the question in a different way. Find all points in the domain of absolute value x minus 2 plus 3 where f is not differentiable. So let's kind of draw a quick graph of this. Absolute value x minus 2 plus 3. So if you recall, this is basically the absolute value graph with a transformation of right 2 up 3. Okay, so the question is, where is it not differentiable? Well, that's kind of easy. We already said differentiability depends on the shape. So it's not differentiable when there is a sharp corner. So we can say that it's not differentiable at 2, sorry, at 2. Because at 2, that's the vertex is not differentiable. So let's go ahead and have you pause the video, find all the points in the domain of here where it's not differentiable. So I'm going to give you a really quick graph. This is basically a half circle, but because it is there's an absolute value, it basically takes this, I guess not really a half circle, but a parabola, and then it pushes up like this. So this is -3 and 3. So where is it not differentiable? All right, you probably have already guessed it. It's going to be at, plus minus 3. Those 2 points are sharp corners, so it's not differentiable. All right, let's try another one, piecewise function. Is the function differentiable at 2? Remember, there are 2 questions. Is it continuous? If it's not continuous, automatically not differentiable. And then, is it I guess, is the derivative the same on both sides? All right, so go ahead and pause the video and try this one. All right, let's think about it. Is it continuous at 2? All right, let's go back to chapter 1. Is it continuous at 2? What's the requirement to prove something is continuous? The limit as x goes to 2 has to equal f of 2. All right, so let's go ahead and check. What is f of 2? F of 2 is using this one. So then that is 2 squared plus 1, which is 5. What is the limit at 2? Limit at 2 is when the left-hand side and right-hand side are equal. Okay, so the left-hand side we said is 5. The right-hand side, let's see, is 4 times 2 minus 3, 5. Okay, the right-hand side and the left-hand side are equal, so the limit is also 5. So it's continuous. Is the derivative same on both sides? All right, so derivative limit as h goes to 0 of the left-hand side. The left-hand side, I'm going to write this definition of derivative out. So the left-hand side of 2, so that is limit as h goes to 0 of, we are finding the derivative at a point, so I'm just going to put in 2. So 2 plus h squared plus 1 minus 2 squared plus 1. So the derivative at a point over h. Okay, limit as h goes to 0. This is 4 plus 4h plus h squared plus 1 minus 5 all over h. This 4 plus 1 minus 5, that's 0. All the h's are going to cancel out, so it's the limit as h goes to 0 of 4 plus h when h is 0, so 4. So on the left-hand side of 2, the slope is 4. What about the right-hand side? Okay, right-hand side uses the function 4x minus 3. So 4 times 2 plus h minus 3 minus 4 times 2 minus 3 over h. Limit as h goes to 0 of 8 plus 4h minus 3 minus, I'm going to solve this part, that's 5, so minus 5 over h. 4 minus 3 is 5 minus 5, that's 0. H cancels, we get 4. So is it differentiable? Yes, it meets both requirements. It's continuous and the derivative from both left and right are the same. So yes, differentiable at x equals 2.